everybody. Today we're going to focus on something called net ionic equations. So you have learned how to predict products of all different 5 types of reactions. Most recently we've spent some time on doing solubility rules, so then that way you can determine if something is going to be insoluble or if it will be soluble. So now we're going to take doing reactions, predicting products, and solubility rules to a new level. So we're going to go even further with it. This is the last thing that we're going to learn for Chapter 9. So remember that your test over Chapter 9 is going to be on Friday. Also, just some other announcements or kind of clarifications. On Monday, I will not be here. I will be at a technology committee meeting at the school board office. So on Monday, we won't be able to do our lab since I'm not going to be present. So we will for sure do your lab on Tuesday. On Monday, we're going to do some practice with these net ionic equations, okay? And based on what you're doing today, if you have questions on this stuff, make sure that you post to the blog so that way I can try to answer you. On Monday, also, if you have questions, I'll have my iPad with me the whole time. So if you're like in class and you're stuck on a question, just email me and we'll like try to work it through based on email, okay? So let's get started. And these are the PowerPoint slides that are still part of our Chapter 9 chemical reactions. I posted them on a few blogs ago, but I will post another set of just the ones that you're going to see right now. So I'll post those as a PowerPoint and as a PDF. So specifically we're focusing today on something called net ionic equations. And net ionic equations are reactions that happen in aqueous solutions. So we know about a reaction that specifically has to happen when 2 compounds are in aqueous solutions, and those are double replacement reactions. So these are also going to be double replacement reactions, which is good for us because I think everybody thinks that those are the easiest ones. Most chemical reactions do take place in water, so we do consider most reactions to be aqueous solutions, or reactions that take place in aqueous solutions. When reactions occur in water, we will call these aqueous solutions. So to keep going about aqueous reactions, I want to do an example of just writing out a double replacement reaction, and then we'll go from there on what I mean when I say a net ionic equation. So first, I want to write out the reaction of aqueous solutions of silver nitrate and then of sodium chloride. So let's go to our Active Inspire and write that out. So we want, again, to write the reaction for silver nitrate. So silver nitrate would be AgNO3, and since it's in an aqueous solution, I'm going to have to write AQ. So we have silver nitrate, and then we also have sodium chloride. So silver nitrate and sodium chloride. So then I'm going to write NaCl. That's an aqueous solution as well. Okay, that is going to make for us what 2 products? It's going to make for us silver chloride. So it's going to produce silver chloride, and it's also going to produce sodium nitrate. So then I'm going to write NaNO3. Okay, I'm not done though. My next step is that I need to make sure that this is a balanced reaction. It is so imperative that when we do these net ionic equations, when we're getting ready to do that, that you have these balanced, okay? If you don't, it's going to make it really confusing. So make sure you have all of your reactions balanced always. From what we're given here, all of these have a plus or a minus 1 charge, so we're good to go. So this one doesn't need any balancing, it's already balanced. The last step that I need to do is to make sure that I use my solubility rules to determine if this is going to be soluble or insoluble, or if this is going to be soluble or insoluble. So if I look at my solubility rules, I'm going to look up silver chloride. I know chlorine is a halogen, and I know that chlorine is a halogen that's attached to silver. That's one of those exceptions. So silver chloride is insoluble, which makes it a solid. And I'm going to look at my other product, sodium nitrate, And I know that sodium is an alkali metal. Nitrates, those are always soluble. So that means that sodium nitrate is an aqueous solution. Okay, so we have out our entire reaction. And we predicted our products, we balanced, we also looked up solubility rules. So let's go back to our PowerPoint slides. So we have our reaction. This is exactly what you guys wrote out. It was awesome. Most ionic compounds can dissociate into ions when they're in an aqueous solution. So what this means is that the compound will break down into its cations and its anions. So let's say, for example, that we have salt, which is what we did have up here as an aqueous solution in this reaction. Salt, NaCl, in water will dissociate, and I realize that you guys can't read all of that. So let me try to work this out for a second, guys. Sorry. Okay, well, I don't think that really helped at all. So salt, NaCl in water will dissociate into sodium ions and chlorine ions. So if I have salt in water, typically what it would look like is I have my beaker of water, and in that water I have sodium cations and then chlorine anions. So it's not really as a compound when it's in water. Instead, they tend to be in their ion form, okay? That's what that means. Okay, to continue on with this, I'm going to leave this like this because you can see the entire slide that way. If a compound is aqueous, then that means that it can break down into its ions. So if I had sodium chloride in the aqueous form, that means that it would break down into sodium cations and chlorine anions. But let's say that I have sodium chloride as a solid. That would not break down into its ions. If it were a liquid, it would not break down into its ions. And if it were a gas, it would not break down into its ions. So the only form that a compound can separate or dissociate into its ions is an aqueous solution. And because of this, this is why we do something called net ionic reactions. So I want to keep going with the reaction that we're working on right now. And I want us to break down all of the aqueous solutions into their ions. Remember that the aqueous solution is the only one that I can break down. I can never, ever, ever break down a solid, a liquid, or a gas. So right now, based on the reaction that we just wrote, this is the reaction that we just did, I want to take that reaction and I want to break the aqueous solutions into ions. So let's do that right now. We had silver nitrate, sodium chloride, and that formed silver chloride that was a solid, and sodium nitrate that was aqueous. Okay, so that was our reaction. We had, again, silver nitrate, it's an aqueous solution. Sodium chloride, it's an aqueous solution. Silver chloride was a solid based on our solubility rules, and then sodium nitrate was an aqueous solution, again, based on our solubility rules. So I want us, again, to break down all of the aqueous solutions into their ions. So first one that we have here is our reactant. We have silver nitrate. So I know that silver is my cation. In this compound, it has a +1 charge, so I'm going to write silver with a +1, and then aqueous, because it's part of an aqueous solution. I'm going to use then my anion, so plus. My anion in this case is nitrate, so I'm going to write NO3. And we know that NO3 always has that -1 charge, so it's a -1, and it's still aqueous because it's part of an aqueous solution. So that's how I break down an aqueous solution into its ions. I had silver nitrate,